Okay, 6.1.2 builds off of 6.1.1 obviously in a nice way in that some of the results you got from the quiz and the practice will help you see this. So we're formalizing the idea that the altitude drawn to the hypotenuse of a right triangle is the geometric mean. And this is geometric mean back from chapter 5. You will see that it is a geometric mean of the two pieces that are created on the hypotenuse. So let's reestablish a couple of things. One is that the two smaller triangles are similar. So, and I've labeled the angles a little bit just so that people can see that we have angle X and angle X over here. If I change things up a little bit, we have 90 minus X here and 90 minus X here. We have the right angles as well marked. So one thing that we can do is try to show a little bit of the two triangles. So here's the conclusion. It's right here. We're going to get there. And the triangles that I'm going to work with are, let's start with the right angle in both. So E, C, B is similar to triangle on the other one, E as well, right? E. Then we went to the 90 minus X side, so there's our angle. So that's up at B and to D, right? So we've done that in the other section as well, where the medium is similar to the small triangle. What's nice is that in the quiz, in the last section, you saw that you could set up a ratio that looks something like this. BE relates to CE. Let's stop there for a second. BE, right, relates to CE the same way that, now again, we started with the side opposite the 90 minus X, so we're going to do that the same over here. The 90 minus X opposite side is DE. And then the side opposite the X is BE. You may see this already happening right in front of your eyes. When you cross multiply, you get this nice result, of course. BE squared is equal to CE times DE. And very quickly you end up with what I've have as the conclusion up there. BE is equal to the square root of this product, CE times DE. And you'll have a chance to practice this a little bit, but what's really nice is that essentially all you need to figure out any one of those pieces is if you have the other two. So if you have this piece and this piece, let's say, you can get the altitude. If you simply have this one and this one, you can get this other piece as well over here. Okay, so really nice, powerful outcome that we did not have before we developed the idea of similar triangles and then started working with right triangles and their altitudes. Okay, that's the end of 6.1.2.